Welcome students. Today I am going to explain about the physical chemistry, and the chapter which I am going to explain you is known as atomic structure. Myself Shamrat De, chemistry teacher in Asian International School. I am going to explain you some introductory part of atomic structure and brief discussion about cathode rays and discovery of electrons. Now, the definition of atomic structure. The word atom is a Greek word meaning indivisible, that is, an ultimate particle which cannot be further subdivided. The concept was put on firm footing by John Dalton in the form of atomic theory in the year 1803 to 1808. The first major breakthrough to suggest that atom was not a simple indivisible particle of all matter, but was made up of smaller particles, showed by M. Faraday in 1833 by the relationship between matter and electricity. Discovery of electrons, protons and neutrons discarded the indivisible nature of the atom proposed by John Dalton. The works of J. J. Thomson and E. Rutherford actually laid the foundation of the modern picture of atom. It is now believed that the atom consists of several particles called subatomic particles like electron, proton, neutron, positron, neutrino, meson, etc. Out of these particles, the electron, the proton and the neutron are called fundamental particles. Now I am going to explain you discovery of electron by cathode rays. The nature and existence of electron was established by experiments on conducting of electricity through gases. In 1859, Julius Plucker started the study of conduction of electricity gases at low pressure in a discharge tube with two metal electrodes sealed on both the ends. You can finding out the entire procedure what Mr. Plucker used on that time by the following figure. Air was completely removed from the discharge tube. Inside the tube, the pressure about 10 to the power minus 4 atmosphere. When a high voltage was impressed across the electrode having more than 10,000 volts, some sort of invisible rays moved from the negative electrode to the positive electrode. Cathode rays possess the following properties. They travel in a straight lines with very high velocities ranging from 10 to the power 9 to 10 to the power 11 centimeter per second. They produce a green glow when strike the glass wall beyond the anode. They produce heat energy when collide with the matter. It shows that cathode rays possesses kinetic energy which is converted into heat energy. They are deflected by the magnetic field as well as by the electric field. It shows that cathode rays carry negative charge. Cathode rays consist of material particles which have mass and velocity. Cathode rays also produce X-rays. These rays affect the photographic plate. The nature of cathode rays is independent of the nature of cathode and the gas in the discharge tube. More important thing, these particles carrying negative charge were called negatrons by Thomson. the name negatron was changed by Stoney into electron. This is very interesting part. Now, in 1897, J. Thomson determined the E by m value of the electron by studying the deflections of cathode rays in electric and magnetic field. The value of electron by mass has been found to be minus 1.7588 into 10 to the power 8 coulomb per gram. I will explain this process briefly in later section. Now, the path of an electron in an electric field is parabolic, given as the following formula: y equal to E divided by 2mv square into x square, where y equal to deflection in the path of electron in y direction, small e equal to charge on electron, capital E equal to intensity of applied electric field, small m equal to mass of electron, v equal to velocity of electron, x equal to distance between two parallel electric plates within which electron is moving. The path of an electron in a magnetic field is circular with radius r given as the r equal to mv divided by E into B, where m equal to mass of an electron, v equal to velocity of electron, E equal to charge on that particular electron which is moving, and B equal to intensity of applied magnetic field. By performing a series of experiments, Thomson proved that whatever be the gas taken in the discharge tube and whatever be the material of the electrodes, the value of E by m always the same. Electrons are thus common universal constituents of all atoms. J. Thomson gave following relation to calculate charge by mass ratio by the following formula: E by m equal to capital E by RB square, that equal to minus 1.7588 into 10 to the power 11 coulomb per kg. The first precise measurement of the charge on an electron was made by R. A. Millikan in 1909 by his oil drop experiment. The charge on the electron was found to be minus 1.6022 into 10 to the power minus 19 coulomb. Since an electron has the smallest charge known, it was thus designated as unit negative charge. Now here I am going to explain how to calculate mass of the electron. The mass of the electron can be calculated from the value of E by m and the value of E, where m equal to E by m, and I am going to substitute the value of charge of an electron and the value of E by m ratio charge, that equal to minus 1.602 into 10 to the power minus 19 divided by minus 1.7588 into 10 to the power 8, that equal to 9.1096 into 10 to the power minus 28 gram, or 9.1096 into 10 to the power minus 31 kg. This is termed as the rest mass of the electron, that is mass of the electron when moving with low speed. The mass of a moving electron may be calculated by the applying formula, that is mass of moving electron equal to rest mass of that particular electron divided by root over 1 minus v by c the whole square, where v equal to velocity of the electron, c equal to velocity of light. When v equal to c, mass of moving electron becomes infinity, and when v greater than c, mass of moving electron becomes imaginary. Now mass of the electron relative to that of hydrogen atom. Mass of hydrogen atom we know that equal to 1.008 atomic mass unit, and it is designated by AMU. Now we know one atomic mass unit equal to 1.66 into 10 to the power minus 24 gram. Therefore, by using this relation, we can easily establish that the mass of hydrogen atom equal to 1.673 into 10 to the power minus 24 gram. Therefore, mass of hydrogen atom divided by mass of the electron equal to 1.673 into 10 to the power minus 24 gram divided by 9.1096 into 10 to the power minus 28 gram, that equal to 1837. Thus, mass of electron equal to 1 by 1837 into mass of the hydrogen atom, that equal to 0.00549 atomic mass unit. An electron can thus be defined as a subatomic particle which carries charge minus 1.6 into 10 to the power minus 19 coulomb, that is 1 unit negative charge, and has mass 9.1 into 10 to the power minus 28 gram, that is 1 by 1837th mass of the hydrogen atom. Electrons are also produced by the action of UV light or X-rays on a metal and from heated filaments. Beta particles emitted by radioactive materials are also known as electrons. Now, Millikan's oil drop method is used to determine the charge on an electron by measuring the terminal velocity of a charged spherical oil drop which is made stationary between two electrodes on which a very high potential is applied. Charge on an electron can be explained by the following equation: Q equal to 6 pi eta r divided by E whole into V1 plus V2, where eta equal to coefficient of viscosity of the gas medium, V1 V2 equal to terminal velocities, E equal to electric field or electric strength, and R equal to radius of oil drop. Note, R, it means radius of the oil, can be also explained by the following formula: R equal to root over 9 eta V1 divided by 2 F minus rho into G, where F equal to density of oil, sigma equal to density of gas, and G equal to gravitational force. So today we explain some introduction part of the chapter atomic structure and how to discover electron, its mass and its charge. In my next class I will explain how we discovered proton and Rutherford atomic model. Till then, thank you very much.